Hi, my name is Ryan Israel. I'm a tech lead with Juniper Network Certification Program. This Learning Byte I will show you how to learn IPv6 BGP routes over an IPv4 BGP peering. This is a topology we'll be using for this Learning Byte. R1 and R2 are both configured for IPv4 and IPv6 on the interface. R1 is .1 for both IPv4 and IPv6, and R2 is .2 for both IPv4 and IPv6. There's just a single IPv4 eBGP peering between the two routers. R2 is advertising two prefixes, one IPv4 and one IPv6 prefix. Let's go to the devices and I'll show you the next steps. We're here on R1, and let's look at the interface config, and we have the family INET address and the family INET 6 address. We're using the IPv4 compatible IPv6 address. It doesn't necessarily have to be that for this to work, but that's what we're using in this example. Let's look at the BGP configuration. It's IPv4 peering with family INET as well as family INET 6. You need the INET 6 NLRI to receive the IPv6 routes. The peering is currently up, but you can see that we're just receiving the INET 4 or the IPv4 route. We're not receiving the IPv6 route. Let's go look over on R2, and you can see the configuration is the same for the interfaces and for the BGP peering. And we're also, R2 is advertising the IPv4 and IPv6 route. So why aren't we receiving the IPv6 route on R1? And if we look in the routing table, you see that we just have the IPv4 route, and the IPv6 is an even hidden route. So the one thing we could do on R1 is to look at we could look at the trace options to see what's going on. And unfortunately, with the way it's currently set up, unless something changes, all we are receiving is keep lives. So it's not going to give us much information. So since this is a lab environment, we could go ahead and clear the BGP neighborship so we could take a look at the other message types, like type the open or the update, and see if we could see what's causing the issue that way. Alright, as that starts to come up, should start seeing the different message types. Alright, now it's back up. So there's our open message. That looks fine. Then in there that tells us what the issue is. And there's the update with the IPv4 route. That looks fine. And then we have the update for the IPv6 route. And then it's having an issue, a sanity check issue. The next hop is not what we have configured. So the route is being ignored, it's being discarded, so that's why it's not in the routing table. And this is what happens when you do IPv6 over IPv4. The BGP derives this address off of the IPv4. It adds this this part to the beginning of the IPv4 address. And that's why with the address that we have configured, there is not a next hop for this, and that's what causes it to be discarded, and the route is not in the routing table. So how can we fix this? There's a few different ways we could do this, but let's say for this instance you only have access to R1. So in that instance you can't change any IP addresses or anything like that. So what options do we have within BGP that we could maybe resolve this? One way that'll work is multi-hop. Multi-hop is usually used when you're configuring eBGP peering they're not directly connected, indirectly. I mean, they're indirect. They're not directly connected. So you usually would use a multi-hop for that type of eBGP session. That will work, but the only problem with using it in this scenario, all the routes that you learn via that next hop are going to now become indirect routes, and you may not want to learn every route from that neighbor as indirect, especially if you're have a multi-path type scenario where that may cause some issues. So the other option we have is accept remote next hop. Now configuring this will allow us to accept those routes that are remote and not make them indirect. So or I should say not make all your other routes indirect. Set and let's go ahead and commit that. Now if we take a look, oops, we see now we're receiving the IPv6 routes, but there still is an issue. Which we already know about because we saw it in the trace option. It's hidden, and the reason why it's hidden is because of an unusable next hop. And how can we fix that? We could do that in this case, the way we're doing it, we could do it with policy. And the policy I already have configured, you could do this many ways, but the main thing is that the next hop is your configured next hop, your IPv6 next hop. So let's go ahead and apply that. And now the route's accepted. And it's no longer hidden, it's active. And we could also test it. Try this again. And we're able to reach the destination. This concludes our learning byte on learning IPv6 routes over an IPv6 BGP neighbor. For more information, you can review the technical documentation for BGP Configuration Guide, and specifically look for configuring IPv6 BGP routes over IPv4 transport, and also configuring a single hop BGP peer to accept remote next hop. Thank you.
Visit the Juniper Education Services website to learn more about courses. View our full range of classroom, online, and e-learning courses. Learning paths, industry segment and technology-specific training paths. Juniper Network's certification program, the ultimate demonstration of your competence. And the training community, from forums to social media. Join the discussion.